Okay, today we're going to be talking about mean absolute deviation. But before we get started, we got to know what it means. So first of all, you're going to use this symbol a lot because you don't want to write it all out. So mean absolute deviation. And all it means, it's a measure that gives the average distance of each data point from the mean, or to the mean. Okay? So we're going to go through the steps to find it, and then we'll do some practice problems together. So first step is we're going to find the mean. Then we're going to find the difference or the distance of each value from the mean. And why do we use the word distance? Because distance can never be negative. So it doesn't matter if this is what our normal distribution looks like, okay? So if this were in a perfect world, this would be a beautiful bell curve, and right here in the middle would represent our mean, the average, and it would be perfect. We would have the same number on this side, the same number on that side, and it would be a perfect distribution. So what the mean absolute deviation does is it takes the data points and it measures the distance from the mean to the mean of our sample population. And distance can't be negative. So that's why we use the word distance, and that's why we use mean absolute, because it's the absolute value distance from the mean. So we're going to find the distance from each data point from the mean, and then we average those distances. Okay, so sometimes it's better to just look at an example. So let's take a look at data set A. Well, the first thing that we need to do is we need to find the average. So we're going to find the average of this data set. So 1 plus 3 plus 5 plus 14 plus 17, and I divide by 5, and we get the mean is 8, okay? So what is the distance from 1 to 8? It's 7. What is the distance from 3 to 8? It's 5. The distance from 5 to 8 is 3. The distance from 14 to 8 is 6. And the distance from 7 to 8 is 9. So now these are the distances, and the mean absolute value is where I add them up and divide by the number set, because now I'm going to average the distances. So I'm going to do 7 plus 5 plus 3 plus 6 plus 9 divided by 5, and I get a MAD score of 6. Now, let's look at data set B. Our first step is to find the mean. So 5 plus 6 plus 8 plus 9 plus 12 divided by 5. And I get a mean of 8. And now I'm going to find the distance, 3, 2, 0, 1, and 4. And I'm going to add those up. 5 plus 5 is 10 divided by 5, which is 2. Right? So 10 divided by 5 is 2. So now I'm going to get a MAD average deviation score of 2. And over here, look what happens. If I add them all up and divide by 5, I'm going to get a mean of 8. Well, what's the distance here? It's 0 plus 0 plus 0 plus 0. And 0 divided by 5 is a MAD score of 0. So what does it mean when you get these MAD scores? Well, when you interpret the MAD score, it means that the closer MAD is to 0, the less deviation that my data has. So there will be the less variation or deviation, the less variation there is in the data. So So it is really, really good to have a MAD score of 0. That means you're smack dab in the average. That's your average score. So that's what we want. We want a close MAD score, as close as we can get to 0. That means we have a pretty great population. So how do outliers affect the mean absolute deviation? Well, if you get one score way out here, that's your outlier and you average it, it's going to make that MAD score go up. And we don't want a big MAD score. So it is going to raise it. Okay? All right, so let's look at some examples here. Find the mean absolute deviation of each data set and round answers to the nearest tenth if necessary. So we're just going to do one example of these. So the first thing we're going to do is find the average. So 71 plus 78 plus 75 plus 74 plus 80 plus 72 and divided by 6. So I get an average of 75, or the mean is 75. So now, so I'm just going to put the mean right here. The mean is 75. So now the distance here is 4 plus 3 plus 0 plus 1 plus 5 plus 3. So I'm taking the difference of all these and finding that distance. And then I'm going to divide by 6. So I get 7 plus 6 plus 3, and all divided by 6. And I get a MAD score of 2.7. That's my MAD score, okay? And notice they're all kind of clustered around. They're pretty centered. Look at my range. I go from 80 to the lowest score of 71. So that's a range of 9. So you can come back. All right, so let's take a look at number 2. So the first part is I'm going to average them up. 100 plus 52 plus 80 plus 96 plus 90 plus 74 plus 86 plus 94. And I'm dividing by 8. And I get an average, I get a mean of 84. So now we're going to take the distance. So 84 to 100 is 16. Ooh, look at this one. I get 32, 4, 12, 6, 10, 2, and 10. Okay? So now when I add them up, 16 plus 32 plus 4 plus 12 plus 6 plus 10 plus 2 plus 10, and I divide by, how many do we say? 8. Oh, I just lost it. So sorry, 16 plus 32 plus 4 plus 12 plus 6 plus 10 plus 2 plus 10 divided by 8. And I get a MAD score of 11.5. And that's a big score. And look at my deviation. I'm going from 100 to 52. So that range of values is really, really big, right? So the closer to 0, the better. All right. Now, let's look. We're not going to do another example. I think you can kind of get the gist of that. But which is a better measure of the variation of data? Range or mean absolute deviation? You could see that the range, that was spread out. So the mean absolute is a much better measure of variation since it takes all the values and their distance from mean. Okay? So MAD is going to be the best predictor on that one. If you're having trouble computing a MAD score, come and see me.